Hey, this is Dr. Allen. We're going to talk about bone remodeling in this lesson. Here are the objectives. We're really going to get into the osteoblasts and osteoclasts. In this lesson, we're going to talk about things that help to regulate bone remodeling. All right, so let's get into this. For bone remodeling, uh, we have two kind of things that happen throughout your lifetime. About every 10 years, all of the compact bone in your body is eventually replaced. So the compact bone that you have right now, say in your femur, is not the same bone that was there 10 years ago. It's been completely replaced by new bone. Same thing with the spongy bone, except a little bit quicker. If you notice, it's maybe less bone density in here compared to the compact. Every 3 to 4 years that replaces. So after 10 years of compact bone replacement, the spongy bone has been replaced maybe a couple of times, maybe 3 times, depending on who you are and things that have been going on. Okay, now let's talk about bone remodeling. I like this image. This is from Visible Body. We have the osteoclasts, which are here. These are these multinucleated cells. They're colored in blue in this diagram. But what I like about it is how it's kind of, you see how it has this little kind of this divot down here? And look at the difference between the matrix and kind of what's going on. So these osteoclasts are going through and they're crunching away and eating up all this bone material. And that's called bone resorption, right? Bone resorption is that's by the osteoclasts. The osteoblasts, these guys here in red, they're building up bone, right? So osteoclasts break down bone, osteoblasts build them up. And then of course we have these little osteocytes. They're kind of these star-shaped, but they're in the lacunae. They have these little connectors between them, the canaliculi, that's what they're called. And they're communicating with each other and they're just kind of maintaining, the proper density of the bone, the composition of the bone in response to stress and that sort of stuff. A little bit more about osteoclasts themselves. So you've seen this diagram before, but the image I flipped and reversed so to make it kind of look like this microscopic view here, right? So this is a microscopic view of bone. Here's some bone matrix. There's an osteocyte within the lacuna right there. This is kind of the bone matrix. We have this thing called a ruffled border of the osteoclast. That's compared to this guy right here. Within the osteoclast, there are things called lysosomal enzymes. Now, we didn't talk too much about lysosomes during the discussion on organelles, but they're just these little blebs inside the cell that contain certain enzymes. And these lysosomal enzymes will go through and degrade, digest the bone material. So here are the two steps kind of involved. First one is secretion of hydrogen ions. As you recall from previous discussions about pH, hydrogen ions are responsible for acidity of a substance. So as it secretes these hydrogen ions, it secretes an acid kind of substance, which dissolves the minerals, and those minerals are calcium and phosphate. Once those minerals are out of the way, the lysosomal enzymes will come along and digest away the matrix of that bone. And the matrix of the bone consists of a lot of collagen fibers. So that's a two-step process of how the osteoblasts break down the bone. Um, in reality, it's much more complex than that, but this is just kind of what I want you to get to know for now. All right. Once the osteoclasts are done, the osteoblasts will come along and continue the process of building new matrix upon that bone. So how does it do that? Again, the actual process is quite complicated, so I summarized it here on this slide. The text will have a little bit more detail in there, but essentially the calcium ions and phosphate ions will be laid down and applied to the osteoid, create calcium phosphate crystals. Now look at how this is abbreviated, Ca2+. Ca means calcium. This 2+ means that it's an ion with a double positive charge, right? And we talked about ions way back in the beginning. And then the phosphate, I have it abbreviated as Pi. If you recognize that from earlier lessons when we talked about things like ATP, I had used Pi as its abbreviation. So that's phosphate. the I stands for inorganic phosphate. Anyway, so these will form calcium phosphate crystals. One term I want you to know is this thing called hydroxyapatite. It's essentially a mineral salt, forms around these calcium phosphate crystals. This is responsible for the hardness of bone, right? So if you notice in a bone, you pick up a bone that's really, really hard, it's because of this hydroxyapatite substance, which is heavily reliant upon these calcium phosphate crystals. So let's talk about bone remodeling and bone response to stress, because that's kind of one of the big things about how bones react and they grow and they develop, right? We have this thing called Wolff's Law, which states that bone will grow or remodel in response to the demands placed upon it. One of the things, for example, is compact bone, which is thickest in the middle of the diaphysis, right? So if we take a look at let's just kind of go like this here. So if this is a bone here, remember the diaphysis is this middle part right here in the midsection of the bone. The epiphyses are kind of here on the end. But if you imagine some of the stress on a long bone, there you could have like kind of like a bending stress, right? And where does the pressure mostly occur when that? It occurs kind of in this middle part. So as a result of this stress, you could have thick compound or thick compact bone in the middle of the diaphysis in response to this bending stress that's placed upon it. Now the other thing that could happen is we talk about handedness. So I'm right-handed, so therefore my right arm and hand bones will be slightly larger compared to my left. That's because I tend to use it more often, put more stress based on the muscles and the attachments of the muscles and things like that. And so that's can lead to a little bit of asymmetry between your right and your left side. Other things that can happen is there's little projections on the bone, right? And that's where muscles, ligaments, and other things attach to bone itself. So imagine right here, there's probably some this is the femur bone, right? So there's probably some big, strong muscles of your leg that attach right here to this spot. Maybe some ligaments that attach to the pelvic bones. But as you exercise and move your legs and do work and all sorts of stuff, this little area here will grow and respond to the stress placed upon it by those muscles. And that's how you end up with these kind of the feature of these bones here. Like see how there's like these little nubbies that kind of stick out and these ridges and that sort of thing. That's just because of where the attachments of structures to that bone. On the flip side, you can have limited use or no use of your muscles, right? So let's just say you're in a coma and you're bedridden for months on end. Maybe you're paralyzed or something else. If you're not applying stress to your bones via muscle actions, your bones will actually start to get weak and they will do something called atrophy or kind of breakdown, right? Because you need stress on the bones for good bone health. Kind of a similar thing happens in outer space, right? For astronauts that are out there, because if they're out in zero gravity for prolonged periods of time, their muscles and their bones will begin to atrophy because they're not putting stress upon them. Sometimes you'll see like astronauts, like in a movie or a TV show or just a newsreel or something, you see them actually exercising out in space, and that's because they're trying to maintain bone mass the best way that they can. All right, so that concludes our lesson on bone remodeling and response to stresses placed upon it. We'll see you for the next one.